Okay, we're now ready to begin to look at one of the first major techniques we want to work with, and that's called time series decomposition. And by time series decomposition, what we mean is that we have a single variable, Coors Light shipments in cans, t-shirts that are red in color, iPads or whatever. We have a single series through time, historical. So from last month back 15 or 20 months. So that's what we mean by a time series. A single series on one of our company products or on our shipments through time, and however many of those periods we have, 10 years, 20 quarters, or 5 months, or 75 days, whatever, okay? Time series. Now, the time series can be both additive or multiplicative. So let's look at what that means. If you look here, where I'm pointing in terms of an additive pattern, and remember, the data can consist of, and we saw that, trend, seasonality, cycle, and random behavior to it. Notice here, these things add together to become our Coors Light shipments, okay? And what's important is that these are repetitive. Now, this is not a repetitive pattern, but seasonality and trend are repetitive, and they are patterns. So if we can model them statistically or decompose them, then indeed we might be able to use that decomposition to put them back together and forecast. In this particular situation here, it's a multiplicative pattern, not an additive pattern. So in a sense then of what would we have to do, you can see very easily that if I wanted to decompose the data, I wanted to deseasonalize the data, then what I would do is I would subtract from Y some seasonal pattern, the seasonal pattern here, and then that would give me, for lack of a better word, what we call the deseasonal part of it, okay? Now, if I was doing multiplicative data, then what I would be doing is not subtracting it out. I would divide it out, and then that would then give me the deseasonalized part of the data, okay, deseasonalized part. And if I could indeed break it down into analyzing the trend and then analyzing the season and then put them back together into the future, I could get a forecast that way. In this particular case, if I could get a value for the trend in the past and then multiply it by the value of the seasonality in the past, then guess what? I could get a future forecast. So at the heart of this simple and very popular technique is a very simple notion, and that notion is, okay, that for additive, if I can take the seasonality out, oops, let me go back one. If I can take the seasonality out, I get deseasonalized. That would be the trend. If I take the trend out, subtract it out, I would get the season. If I could then do that and identify both of those parts, I could add them together and forecast. Here I divide it out, okay? So that's the difference. Now, let's go ahead and look at some actual data, all right? So what we have here are 16 observations, okay? 4 years, this is quarterly data, 4 quarters. So what I have initially then is the actual data. What I'm going to use is a technique as described in your text called a 4-period moving average, because that works well for quarterly data. I'm going to add 72 to 110, 117, and 172, okay? And divide that by 4. That becomes 117.75. Then I'm going to take 110, 117, 172, and 76, divide by 4. That becomes 118.75. That simple moving average I'm using because it is a good representation of the trend. So asking why am I doing a moving average? The moving average is a very good representation of the trend. And if I were to divide that moving average into the actual data itself, it would leave me the seasonal part of the data. Okay? So now what we're going to do then is, unfortunately, if you'll see here, this is 1, 2, 3, 4 divided by 4, okay, leaves me in a really interesting position. It puts me right here, all right? And that's not a quarter. That's not a quarter. And so that's not what I want to do because I can't use that because I don't have the middle quarter. But watch what I could do. If I took this simple moving average, which was the first 4, and I took this simple moving average, which was the second 4, added them together and divided by 2, it now gives me 118.25. And notice now that puts me right here at quarter 3. Now, what is it I'm going to do? Well, what I'm going to do is that this is multiplicative data, and as I was showing you here, I'm using the moving average to represent the trend here. And I want to identify the seasonal part. So I'm using the moving average to represent the trend. So in the first example that I showed you, what I'm now going to do, we divided through by the season to get the trend. Now what I'm going to do is divide my data through by the trend represented by the moving average, and that's going to leave me the seasonal parts, okay? That's going to leave me the seasonal parts, all right? So that's what we're doing here. So this is my representation of the trend. Notice now, I'm going to divide it into 117.8. So 117 divided by 117, so I think I said that wrong, 117 divided by 117.25 gives me 0.98. Okay, so what that tells me then is for the third quarter, okay, relative to the trend, I'm down about 10%. Now, notice, here's my trend number for the fourth quarter of the first year. I'm going to divide it into 172. That gives me 145, okay, roughly. What that is telling me is that relative to trend, because notice now I'm dividing through by the trend, so this is relative to the trend, I'm about 45% above. So as I go through here, then what I'm doing, because this is multiplicative, I'm referencing the seasonality relative to the trend. The trend is 1.0. So roughly here in the third quarter of the second year, seasonal and trend patterns are almost exactly the same. All right, so as you can now look, let's take a look here. So this is the actual first quarter number we came up with, 0.629. So here's for the second year, 0.629 for the first quarter. For the third year, 0.600 for the first quarter. And then for the fourth year, 0.589 for the first quarter of the fourth year. Those are the only three I have. Now, I don't want completely different estimates. I only want one estimate for the seasonality in the first, second, third, and fourth quarter. So I add them up, divide by 3. I don't know what I'm talking, divide by 3, and that gives me 0.6. Add these up, divide by 3 gives me this, gives me this. So what this is saying is that in the first quarter, now notice, let's look at it this way. Let's say this is the holiday season. Then what I can see is that in that fourth quarter, the holiday season, I can expect sales almost 50% over my trend normally because of seasonality. But when I move into the new quarter into January, February, and March, my sales relative to trend are going to fall off about 40% relative to trend. That's seasonality. Now, note, then, in this particular case, do you note that they did not add up to 4 when and they need to add up to 4 because it's quarterly and multiplicative. So this little gimmick here is a simple way of forcing it to add up to fourths. So we call these the unadjusted index, and we call this the final index. So now for each of our 4 quarters, all right, we now have the seasonal index. First quarter is below. Second quarter is a little bit below, about 10%. Third quarter is roughly on trend. So this is, remember, relative to trend. And then my fourth quarter is a huge quarter for me. I'm going to be almost 50% above my trend sales in the fourth quarter of the year. And that's my seasonality. And I'll show you later on how we can use that with also an estimate of the trend to then come up with a forecast into the future.